how we roll there. Some rock, some win, some roll there. Some rock, some win, some roll there. Some rock, some win, some roll there. Some rock, some don't win, don't win.
Hi, my name is Loris Crow, and we are executing a Showtime. Zig Showtime is the show where members of the Zig community come on stream to share coded ideas with the broader public. Every episode features two speakers who will present and take questions from you, the viewers. Zig Showtime is not just what you're seeing on the live stream, but also the discussions that you can have while watching. And that's why I encourage you to join one of the existing Zig communities that you can find by going to ziggang.org. So, hello everyone. Welcome to the episode number 13, so double digits in even more bases moving forward. Let's see. I know that there are some people doing a group watch. Is there anybody doing group watch with... Oh, where is Felix? Felix was trying to do group watch. People left him alone. Oh no. Anyway, so let's go through the news that we have for this week. So let me pull them up in order. So first of all, the LWN article that I mentioned last time now is free for everyone to access. If you go to lwn.com, net, I forget. Well, if you go to LWN, you will find the article. Share it around, take a look, read the comments, and if you want to also share your opinion, feel free to hop into the r/Zig subreddit on Reddit, and yeah, and tell us what you think. Next, newsletter as usual. Zig Showtime has a newsletter. If you are interested, you can read it online. You can subscribe to the RSS feed, or if you're fine giving up your secret email address, plop it into the appropriate field, and you will receive every week. Not exactly always the same day, but you should receive every week a new issue of the newsletter with full descriptions for the talks coming next week, and also other stuff. I added a links section, so that whenever we have somebody reports an interesting link, we'll also add that to the newsletter. And those links could be, projects or something else. On the same vein, the YouTube channel, we are almost reaching the goal to become YouTube partner. Yay! So if you haven't subscribed yet and you're interested in watching this type of content, or sometimes you miss Zig Showtime live, slap the subscribe button so that you won't miss anything. And again, I know I promised some content that comes to YouTube directly without passing through Twitch, and something is coming. I don't want to make extra promises that I'm not going to maintain, but I'm thinking of something in that regard. So there's that. Next point, as I mentioned, no, I haven't mentioned. I think I mentioned it in the pre-show, but Nipsey is organizing a group buy, so we are now in the interest check phase, where he has a Google form that is also linked in the newsletter. By the way, Nipsey, if you can share the link also in Twitch chat so that people can access it more easily. If you think you might be interested in buying a plushie, fill the form. It's not legally binding, so it's just to check that enough people, that there is enough potential interest. After that, if there is enough people interested and Nipsey can actually get it done, then there will be another form, I guess, where he'll take actual orders. Next, oh yeah, we have a interesting talk coming up. And before I go into the introduction for the speaker and the talk itself, let me do a pre-introduction. So it's the talk. If you've read the newsletter or even watched the intro, you should see it's about using Zig on the PSP. So just related. I know there's people that always think that, like, our first ever talk was Benjamin Fang with his Game Boy emulator, and everybody thinks of the Game Boy as the iconic console that everybody wants uh, to hack around with. And but yeah, it's we're getting to a point where people like Benjamin are old. Benjamin, if you're here and you're listening, I'm sorry. Uh, you're not even like cool old school anymore. Now we are getting to a phase where it's the PSP, the cool console to hack with. And in that regard, we also made these, I don't know what to call it, art maybe, I don't know, you tell me, but we made this image that's Metal Zig Solid. If you never played it, it's a nice game. There's also a review at the bottom. So we were sharing this image on Twitter. I just wanted to mention it here for people that missed it on Twitter. So yep, there's also that. I don't know. We're dumb. I'm sorry. I don't know what to say. There's no excuse, but we did it. So we should. I thought we should own it. Okay, so now that you know about Metal Zig Solid, I think we can move to the talk and introduce it finally. So, Nathan has been interested in console hacking since he was very young. Around 2007, he got his hands on a PSP and has never let go of it until this day. One day, we might really get our very own Metal Zig Solid pointer walker game, but to build a world without architecture and API borders, we first need to create a language to surpass C++. And I think we might have. The talk is Zig on the PSP. Nathan, the stream is yours.
Hello, thank you, Christoph. It's a pleasure to be here. So my talk is Zig on the PSP, how I learned Zig and I learned to love it. So really quick, who am I? I tend to ask myself this a lot. My name is Nathan Bourgeois. I recently turned 19 over the summer. I'm studying at The Ohio State University for Computer Science and Education. I've been a programmer since about grade 5, which means that technically I've been programming for a decade, and wow, I really start to feel old now. I run a YouTube channel at youtube.com/iridescence. I do a lot of programming, PSP hacking, and overall just some pretty cool content. And I am a PSP homebrew developer. So, of course, the main subject of this talk is the Sony PSP or the PlayStation Portable. Now, I think we would consider it a retro console, even though sadly it doesn't feel that old to me. It's incredibly powerful for what it was at the time, featuring two MIPS R4000 based processors at 333 megahertz, a vector floating point unit at 166 megahertz, capable of doing vector and matrix operations at much faster speeds than by CPU. And it also features the GPU running at the same frequency. It has 32 to 64 megabytes of RAM, and you can cram in up to however many gigabytes of storage your SD card can fit. So why would you make homebrew in the first place? Well, number one, I think it's really fun to do because, hey, it's an old console. It's something that maybe you had during your childhood or sometime during your early adulthood. And it's something that's really just a fun sort of topic to mess around with. You can go ahead, create these little apps, and you can just have some nostalgia for the device. The second thing is that it's actually kind of challenging, namely because you have restraints. You have restraints and constrictions placed upon you. The CPU isn't necessarily the greatest thing in the world. You don't have infinite amounts of RAM. You don't have, the shiny new RTX 3090 sitting in your computer there to go ahead and render the state of the art graphics. And you really have to start working and thinking outside of the box to go ahead and accomplish whatever goal you have. Another reason I think that's kind of growing is that we have a community. We have a Discord server, about 3,000 people, and personally, I have a community of about 1,250 people. There are a lot of people who are still interested in making homebrew games and doing stuff like that, and it's really fun to talk to various people around the world about just developing for this console. I think, in my opinion, it's sort of the sweet spot of specifications. It's not like too restrictive to where everything needs to be written in pure assembly, but it's also not too forgiving, as in you can't just assume that your latest ray tracing program is going to work on it just fine. It's very open and well known. The PSP has been, basically hacked and exploited and reverse engineered for so many years now that we practically know a large portion of what you need to know about the PSP, its OS, and a lot of its protocols. And finally, creative problems and solutions. On hardware like this, you're gonna obviously encounter some errors that you just never would think to expect on, a modern PC or ARM. You're gonna have some weird case where, oh, you're writing to the data cache and that doesn't make any sense, and you're getting garbage data and all of these different things, and you have to create different solutions to these problems. Make sure that you're checking everything, and make sure that you're writing good code. So, where was the Zig? Earlier in this year, the project called Rust for the PSP was born, and it showed that LLVM had a place. And what I mean by this is that previously, before this language showed up, pretty much there was no sort of LLVM support. There was some experimental support way back in 2011, 2012 that was removed for quite a while now. And basically, everyone had just accepted their fate and used GCC and C or C++. With Rust PSP and some pretty much stock LLVM, basically we could go ahead and create apps with LLVM, and it really started to work and show that any LLVM language could probably work on the PSP. So I was inspired by Rust and obviously Andrew's talks about Zig. Basically, I had watched a lot of his presentations at conferences and stuff throughout the earlier portion of the year. I was really interested in starting a journey on Zig. So I decided to start my journey on July 31st, 2020, on a live stream. It's still live. It's 3 hours of me just trying to figure out how do I even use this language. So how did that go? It was kind of like tripping on a landmine, getting thrown into the air, and somehow executing a not so perfect backflip. It was very hacky to say the least, with some Rust tools, maybe a cryptic looking bash script, some linker wizardry, a few bits of assembly and C sprinkled in, and somehow it ended up working. We got an application that booted on the PSP that was written with Zig and compiled with Zig. So obviously, we have to go somewhere further with this now that we know that it actually works on the PSP. Basically, we had to add some common utilities. For example, printing to the screen. Actually being able to see that your code is doing something is generally a very good idea. So adding text printing, stuff like that. Um, Alongside of allocating memory, which might be important if you actually intend to have an application that isn't pre-allocated. Alongside having the home button, because without having the home button enabled, if you don't know, if you press the home button in a PSP game, it brings up a little menu that allows you to exit the game. Without that, you're kind of stuck in the water, and you have to like hard reset your PSP, which just takes forever because you have to pull out the battery, put it back in, turn on the system, and then get back into whatever you were doing previously. Another important thing was adding all of the system libraries, so the libraries that are given by the PSP OS to the user for them to make applications. That's pretty important if you're going to make an application. Using some Zig only tools. So, for example, I don't want to have make the end user have to, install Rust or install the old toolchain. By the way, the old toolchain still can take up to 2 hours to install. So definitely making some Zig only tools would really help that. I wanted no dependency on Rust just as a general self-hosting thing, and I wanted to have some efficient and effective code with some Zig specific features and some safety. So, Zig PSP tools. In order to generate a valid working executable for the PSP, you need a PRX, an SFO, and a PBP file. Now, that might mean a whole lot of alphabet soup, but let's go ahead and walk through it. An SFO is basically a descriptor of an application or a save file, and it's a key value map. It starts with a sort of header section that tells you where the keys are and where the values are, and then the length of each one, the alignment and padding and stuff like that. And then basically it tells you all of these different keys. Once you parse these keys, they have different meanings. For example, what's the title of your application? What is, the minimum firmware version that you need to be on to run it? Stuff like that. Really basic sort of properties that you need. Furthermore, then you need a PBP file, which is basically a packed binary file. It's essentially an archive with a header on top that tells you where each file is located in the file. So it's an archive that's not compressed. Basically, it has like the background image if you want one, like the icon of your program if you want one. It has to include the SFO and it has to include the PRX executable. PRX is basically a portable, relocatable executable because we need to start EX with X. It's basically a very special type of ELF file with some custom MIPS and custom Sony stuff inside of it. Right now, that tool is actually still in C, but the rest is in Zig. So for the SFO tool, basically you can go ahead and write these SFO files and read these SFO files. You can also take it from a JSON file, which is something new, and basically it allows you to much easier uh, modify it than having to enter in a bunch of command line arguments. For the PVP file, it basically can pack and unpack these PVP files. So for the PSP OS APIs, it's really important for any homebrew game or any general purpose application to have access to the OS API in general to make anything. Basically, you need to have small and efficient wrappers around this sort of thing, and you have to be able to make it basically functional for the end user. Uh, One of the problems that was encountered with the initial Rust adaptation, it's fixed now, by the way, but was that wrapper size was very huge because of some strange issues with ABI mapping. So the modules, basically each sort of little library that you want to include, every driver, as you could say, would basically be its own module. These modules start with the EABI call. These modules have functions inside of them, which have the EABI calling convention, which LLVM isn't using. It uses O32 instead. And then basically you need module support for import structures. And what that means is that basically to have your functions imported, you have to generate a stub method, and then have an information structure of what functions that you are importing. And basically, you put this inside of your ELF file, and then the program loader decides to try to resolve these and do that. And the function IDs are NIDs or named identifiers. They're basically a SHA-256 hash of the function name, and it's the first several bytes of that for which functions that you're trying to include. So, doing it the Zig way, how did we generate this? So we generated these structures using compile time global assembly, and by doing compile time global assembly, we were actually using these assembly code generator sort of macros. So they're basically stitching together some pre-known information and putting it into a full assembly file, and then having Zig the compiler decide to compile it. Uh, this way, we could have them all in their different files for each different module, and then basically each one would be lazy analyzed, meaning that you're only importing what you actually need in your application. Furthermore, for the ABI clashing issue between EABI and O32, basically there was a comp time ABI wrapper that I made. It was pretty cool. Basically, you take in a variable number of arguments and then give a stub, and then basically it will call it with those arguments instead of the actual function being called with uh, O32 when it's supposed to be EABI. So this way, it's a soft wrapper around it that just lets you have these functions that will work. And it's critical for a lot of the standard OS functions that have more than 4 arguments for this to happen. So what does a hello world look like? So right here is the basics of a hello world. Basically, you say const PSP equals import PSP utils PSP.zig. You could actually do this multiple ways. There's different ways to import certain modules, but you're going to generally need a few certain modules that are grouped up in PSP.zig. Basically, you want to run a comp time global assembly block with the PSP module info macro to generate some of the module information, which is needed for your application to actually be run. So the first argument is the title. Then the next one is whether it's a kernel mode or user mode PRX or module. Basically, right now we're not running anything in kernel mode, so it's all in user mode. And then the next one is the major and minor version of your application. Finally, we have pubvin main, and then you can have the type after that. This does support error set or error union types with a default error handler. Inside of this block, then we have PSP utils enabled the home button callback. That's what that stands short for, so that you can actually exit the application if you want. And then you run screen init, and then you go ahead and print hello from Zig onto the screen. Now let's go ahead and actually take a look at the example. I'm going to be running it through an emulator, but this is the same exact example here. Slightly different spacing because I need to fit it on the slide. And if we go ahead and just run zig build, it goes ahead and builds the entire thing. We can go ahead and run the eboot.pbp file in a PSP emulator. And as you see, it says hello from Zig out onto the screen. So switching back here. So what were some of the results? Well, the code is tiny. It's actually really small. It's smaller than the default C example by about 91%. Zig build does everything for you, and it doesn't necessarily have any complicated make files, any weird build scripts, anything like that. And it also supports complete user mode functionality. As you can see by the screenshots below, the PBP tool tells us that we have an application size of 6,842 bytes, and the GCC default is about 68,000 bytes. So we're 90% smaller than that, which is a really good improvement on the GCC toolchain. Furthermore, let's go ahead and take a look at some more of these examples and how we're actually going to be doing it for most user mode applications. For a lot of the user mode applications, you want to go ahead and just git clone, and then we're going to go https github.com/zpsp-dev zig PSP template. And this downloads an entire template. You're going to need the recursive flag because it does include submodules for every tool. So just doing this, we go into Zig PSP. It generates all that. Go into the Zig PSP template, and we can just go ahead and run Zig build. And that's all that it takes to start a Zig application. It compiles all of the tools that you need. It compiles the SFO generator, the PBP tool, the PRX generator, and then it can also compile your application with it. And as you guys can see, we actually have it completely built. So that was pretty simple. So what else can the toolchain do? If we want to go ahead and open up some of these examples over here, we can go ahead and take a look at maybe let's do some allocation support. So allocation support. It's going to build, and it builds really quickly, by the way. Basically, now we can track the number of bytes. What we're doing in here is that we're basically going to go ahead and create a string from these different sections here. So hello from Zig, each one. So we're going to allocate that and use an allocate print. And then we're going to go ahead and free it afterwards. So we go ahead and this is before everything. We print it out after we allocate it. So what we have left after we allocate is this many bytes, and then we go ahead and free those bytes, and then there we go. We're at the end of the application. Furthermore, this supports panics. So basically, if something goes wrong, everything panics. Let me just check that we're in release safe. We should be in release safe. Okay, so now that we're in release safe, we're going to go ahead and build this application with panic support. Panic support is just pub const panic, PSP debug panic. Then we're going to go ahead and run it, and it's going to say the PSP has panicked. Reason for an integer overflow, because our function here is add 1 to 255, which, as you know, causes an integer overflow. So we have safety through that. We also have pancake mode, which says the PSP has pancaked. Furthermore, let's go ahead and view a more impressive example, which is the cube example. Right here is pretty much written in the entire PSP graphics utility. It allows us to set up a 3D context. What it does is pretty much sets up pretty much basically OpenGL 1.3 like interface, and you just have to go ahead and submit vertices to it. And if we go ahead and build it, we're embedding our texture inside the file, by the way. We're going to go ahead and run it. And as you can see, we have our Ziggy the Ziguana basically on the cube, and it's going ahead and rotating. Oops. So what's been added since that? Everything that was just demoed was version 0.4 of the toolchain. Pretty much after this, we've added this the standard library bring your own OS layer. It's kind of a work in progress. Of course, it's going to be a work in progress for a little while. It supports basic input output and most of the standard file system library. So you can create files, you can open them, you can write to them, you can delete them. You can go ahead and create and delete directories as well. And it also includes some other utilities for such as printing with stt.debug.warn to the PSP's standard output or standard error. It also includes the time.zig sort of implementation due to the fact that some of the code is not necessarily completely compatible. We've also added a safe wrapper for the C API, so it's a small wrapper on top that catches errors and things like that, and sends them as actual errors to Zig. And then we also have pretty much that's all that we've added in version 0.5. It includes some of the documentation as well. And Zig PSP's version 0.5 released about 10 hours ago, so it's actually up and ready for you to go ahead and use as soon as you want to. So some of the things that are planned to be added in the future are a compile time VFPU assembler with proper parsing. So tapping into the VFPU, which is majorly faster than a lot of different things on the PSP. Pretty much faster than the main FPU in most operations by up to 40 times faster, depending on what sort of data you're doing. So it would be really useful to have a compile time assembler that would basically do that for you. It would essentially just have to translate your VFPU opcodes into the correct basic instructions that you're going to be submitting. I also want to add support for the custom Allegrex instructions because not all of them are uh, basically added, and Allegrex is the name of the PSP's processor. Also want to add support for plugins. Plugins are sort of a feature that allow you to run a custom PureX module at any time. So, for example, in the main PSP OS, it could be during a game, it could be during emulation of the PS1 as well. So there's different times that you can use plugins, and I'd love to add some of that support into the PSP. I also want to go ahead and make full documentation, and what I mean by that is generating it through the Zig document generator, as you can see with stuff like Lola and the standard library, of course. I'd also love to add kernel mode programming. It would be a cool feature, definitely to add. Uh, I do have to warn you, don't mess around with kernel mode because you can really break things if you really try. Um, yeah, just be very careful that you don't turn your PSP into a brick. Uh, Another thing that I want to add is encrypted PRXs, which would be just a PRX signing tool. This already exists, and I'm pretty sure it would just work from the main GCC toolchain. But you never know; there might be still some differences between how that works. I'm pretty sure, though, that that tool can actually still be used to sign PRXs right now. And then furthermore, I want to finish, as I said earlier, that PRX generator in Zig, because it would be very good to have a fully Zig toolchain. So PSP projects that are currently or in the future going to use Zig. Craft Server, which is a cross-platform Minecraft server. It's one of my personal projects. Currently, the status of that is that it's compatible with Java Edition 1.15.2. It has basically it has a login system already. You can send chunk data and you can send light data. You can also do chat and stuff like that. It also has handlers for movement. So it's actually at a pretty good state so far, and it just needs to backport it over to the PSP. The next thing is the Game Jam engine, which is a very generic name for a very generic game engine. It's something that I've been working on for a little bit now, and I'm preparing to do a demo for it next week, hopefully. And it's to be used in the community game jam, which I'll talk about later. And then finally, Project Dawn, which is going to be sort of a big project that I want to take on, which would be doing sort of a new OS and UI system. It would include a lot of new and modern UI design alongside with newer features for the PSP, like, for example, having multitasking apps for once. That would be something really nice. And maybe some nice modernizations and ease of use for programming. Not all of it will necessarily be in Zig, but I hope that most of it can be done with either Zig or Clang together, working together. So I'm going to go ahead and ask you guys if you have any questions. Below here are the links. The first one is to the overall project. The second one is to the project template. Then the next one is to my YouTube channel. And the last one is to our Discord server.
Thank you very much. That was awesome. So I think we have already a couple of questions, but I'll give a moment to chat to think of other questions and type them up in chat. In the meantime, I'll just as a quick reminder, to ask a question, you can type it in chat on Twitch. Maybe try to tag me so I won't miss it. But at the same time, if you are on IRC or on Discord, you can also write your question there, and I'll be able to find it and relay it if you need it. If you want me to, sorry. Okay, so in the meantime, let's see. So that was really something. So I want to ask you how you discovered Zig, because you pretty much answered that during your presentation, right? You discovered it while hacking on the PSP, while live streaming also, which is awesome. And yeah, I think that I think it's really interesting. Maybe it's not for everybody to watch like a 3 hour long video, but if you're curious to see, if you're curious to see the mental process of somebody going through something the first time, and I think it's interesting. I occasionally do watch long videos like that. Maybe not all in one sitting, but yeah, I think it can be entertaining. So let me start with. So let's see. There was a question from before. Porosion. Well, anyway, sorry, I'm awful at pronouncing nicknames. But the question is, I'm coming from the Nintendo DS scene. Is there any
Alright.
document like GBA tech for the PSP documenting the entire hardware?
All right. Okay, that's actually a very relevant topic. So one of the things I do is PSP tutorials and stuff like that. And right now we're working on basically revamping our wiki. Our previous wiki went down, so we started a new one. And basically, I've been working on getting a lot of articles on there for different sort of things. Right now, it's kind of at a basic stage of just install the toolchain, how that stuff sort of works. But I want to go ahead and work more on that. As an individual and as a community in general. I know that there are a lot of people who are interested in that sort of thing, and I think we're still making an effort to try to get more people into the scene. Another thing is that the original C documentation has quite a lot of useful information if you're into reading technical documents.
Okay, so still from the same user, another question is about the size comparison between what you get from Zig build and what you get from compiling with the GCC toolchain. The question is, does the GCC toolchain use flags such as function sections, data sections, WI, GC sections, LTO? And I'm guessing these are all flags that end up reducing the size of the final executable.
The GCC toolchain, from what I know, doesn't use function sections. I could be wrong about that, but I don't believe it uses function sections. And then it also, I believe, doesn't do LTO yet. I think you can probably do it, and I think that there are definitely ways to reduce the size, but I'm trying to compare it in the sense that what is the default output between the two? You definitely can massage your code to be very, very small. I've seen that happen before, and I've seen people do that, so I know that it is possible to definitely get code as small as this as well. That being said, I'd also like to say that the C standard library is what takes up almost the majority of the executable. And some of the things can't necessarily be just completely garbage collected out of the main. Com- a lot of the things can't necessarily just be, dead code stripped away from the main GCC toolchain, mainly due to the fact that for some things such as function data and stuff like that, it needs to be preserved in order for the application to work correctly. So in that sense, it's kind of a logistical issue.
hmm Uh, so another question from me, maybe we can also give some information to Poro um, from the point of view of Zig. But before that, do you link with libc in from the Zig version?
From the Zig version, we do not link with libc, mainly because it adds a lot of extra weight that isn't necessary.
hmm Okay, thank you. So I wasn't aware of, I wasn't sure about that detail, but then maybe I can also say something to Poro. So the idea is that from in Zig we don't strictly depend on libc, but the Zig can depend also on other libraries like other implementations like Muscle. And in general, also another point is LTO. For example, in Zig there is no LTO step because everything gets compiled at a single compilation unit before getting to the linking stage. So there are a few assumptions that don't hold in the Zig ecosystem. And if you're interested, you might want to look into that a little bit more. Maybe they might provide other interesting properties for what you are trying to achieve, which in this case, for example, a small binary size ends up being something quite useful. Um, let's see, another question from Nipsey. Is the SDK limited to a certain generation of PSPs, or does it work for any PSP?
It works for any PSP. Pretty much, it's all cross compatible because basically all of the functions are the same on every single PSP. You do need a custom firmware on your PSP, but that's been something that's been true for the last 10 or 11 years. So basically everything is cross compatible no matter what version of PSP you have. The memory size is different between the 1000s and any generation higher. And this is the original 1000, by the way. The new E1000 and N1000 ones are 64 megabytes. So there isn't any functional difference between the two. There are some very minute changes inside of some of the kernel libraries, not necessarily exposed to the user.
Awesome, thank you. Let me see. So, d- uh, it's a bit too early for that, I guess. But do you think you seen some of the work done for the self-hosted compiler? Do you think you would get some advantage in maybe in the future implementing some of the functionalities that you offer through the SDK as like a new target for the Zig compiler?
I can't quite comment on that. I don't necessarily have enough information on how that sort of thing would work. One thing that I think would be pretty cool would be if there was a way to, count references to a function, to an extern function in this case, because by doing that, we could go ahead and specifically count with module imports what functions we exactly precisely need. And in some cases, that can be uh, up to 50% less code size taken up as well.
Okay.
Currently, the only way that I can really estimate that that would be possible would probably be with an external tool.
Mm-hmm. Mm-hmm. Understood. Um, okay. I think that was it in terms of questions. Let me double check that I'm not missing uh, anything. Let's see. People invoice. No. Okay, we should be good. So before we move forward, is there anything else you want to say?
Yes. For one thing, one last thing, if you're interested, the PSP Homebrew community is in fact having a Halloween game jam, and in this game jam, we're going to be making sort of Halloween themed games. It starts on October 23rd and lasts through October 30th. It's a 7-day game jam. The winner will be announced on Halloween itself, and you can use any language and any engine. You can actually start building your engine ahead of time. You don't have to build it at the start of the jam, and it's pretty much just a jam for fun and having some fun writing some code. So the Discord link is once again down there.
Okay, thank you very much. That was an awesome talk. I'm looking forward to get an update on how everything is going in the Zig PSP in the PSP community, and how everything is going with the Zig PSP SDK development. So thank you very
All
much
right.
again, and
Thank
and now we can move to the break. But after the break, if you are still here, we're going to talk about how to solve common pointer conundrums. So it took me a while to find a final title for my presentation, but I finally found one that I'm happy with. And so if you want to talk about pointers, don't stay away, and see you in 10 minutes. Okay, almost ready. I just need to finish setting up my speaker view. Speaker view. Please have it. I mean, presenter view. Yeah, thank you. Okay. Here. And finally, let's take a look that everything looks good. Perfect. Right size. Okay, everything seems fine. Okay. Welcome back. Welcome back to Solving Common Pointer Conundrums. So, I know there was a different title at the end of the last presentation, and there was a different title in the newsletter, but I was a little bit late with preparing this presentation because I was working on the website and it was a busy week in general. And the problem is that I knew I wanted to cover some things about pointers, but at the same time, I didn't know if there were enough points and if maybe the presentation needed to also cover other things that weren't related to pointers at all. And I said this in the newsletter, but for the people that haven't read it, I'll also repeat that I try to make these presentations interesting both for newcomers and for people that are more experienced using Zig. And so it wasn't easy find an angle also to this time to make a presentation useful for everybody. So we'll see how it goes. So solving common pointer conundrums. For a brief moment, I was thinking of maybe titling the presentation, wet as pointers. Wasn't sure, but one reason why I ended up not doing it is because I think this should be entertainment for the whole family. And by for the whole family, I mean that this talk is both for new people, for newcomers to the language, but also for experienced people. And the idea is, if you're new, hopefully you will learn something from this presentation. But if you're experienced and you probably know the answers to all these questions, what you can learn is where these questions come from. So the questions that I chose to answer in this presentation are not completely arbitrary. They are based in good part on my personal experience, but they are generally meant to be answers. They're meant to be questions that people that know how to program, that have programmed in higher level languages, that have used pointers and references, and they understand that indirection mechanism in general. So they're used to this stuff, but they come to Zig. They're not used to manual memory management. They are not used to some of the finer details that you have to deal with and decide on when working with a language like Zig. So this talk is mainly for them. So in other words, this is not going to be a full introduction to pointers. If you have never used pointers in your life and you don't know what they are, what they should do, and they confuse you, I'm sorry, I'm not going to address that in this presentation. The assumption is you've used, I don't know, Java or Python, and you understand that when something is a reference, you're touching the original value, even though you are referencing the same, even though you are using a different variable, because multiple variables are referencing the same underlying piece of memory. So in other words, the main objective is to make your code compile and run well enough. So it's not even a matter of make everything perfect. It's to make sure you don't get stuck. And also another point is, as usual, my presentations are imprecise. So I'm sure you will find that I will gloss over a ton of details. But again, the idea is to make sure that people don't get stuck, they get their stuff compiling, and then you can opt into understanding more and more of the details as you move forward. And also because I want to give this talk because sometimes the errors that the compiler returns are not exactly the most useful. Sometimes if you don't understand what the mechanic is and you just rely on compiler errors, you kind of get in these situations where you get this kind of reply from the compiler and you get confused and you kind of start going down a weird path. You start thinking weird things, but in reality it's just the compiler was giving you not the most useful error possible. So it's also to help you not get stuck in those situations. So let's start. Slices versus arrays. In Zig, you have both, and slices are actually very innocuous. But again, you've not used them, you've never seen them. There's slices everywhere. What do you do? They're scary. So let's take a look at how to deal with slices. So this is a very simple sample program. What we are doing here is, while we have print, we are in main, we have an array, and this is the syntax for an array. So this is an array of 5 U8s, right? 5 bytes. And they happen to be equal to hello. So this is more or less a string. There is no string type in Zig. In Zig, strings are sequences of bytes. Now, so we have A that is an array. Then we have B, which is of type slice. So when you see the square brackets but nothing inside, that's a slice. And this the B is initialized to A sliced from 0 to ... which basically means the end, right? So I don't think I have to explain the syntax. This is just like slicing the array from beginning to end. But this is not producing a new array. This is producing a slice, and the slice is a pointer basically plus length, and allows you to point at memory somewhere else. Then we have C, which in this case we're doing something different. We're saying C is of type is of the same type as the array, and we are initializing it to a to the value of A. So we are copying over everything. In the end, C is going to be a different area of memory, and you can see now that if we modify A in the first place, and instead of hello now is a cello, musical instrument, which I believe, yes, you write this way also in English. Now, if we try to print everything, and we try to print A, then we try to print B, and then we try to print C, the result is going to be cello, because we modified A. It's going to be cello again, also for B, because B is referencing A. And then C, since C is a full copy that was made before we modified A, C is still going to say hello, ironically enough, even though it starts with C. This is super basic. I think that there shouldn't be any surprise here. But we start peeking into what I think is one of the things that can trip people up the first few times. And that is that this is an array, this is a slice. When there is no number between square brackets, it's a slice. The difference is that, well, there are different types, but in general, the idea is that slices contain a runtime length, so you can modify their length at runtime, while arrays, the length is known at compile time, and that can change because that's part of the type. So to recap, slices are just a pointer plus a length, so that they are bundled together. You can think of them as a struct that contains two fields, one the pointer, one the length. And they're bundled together so that you don't lose pieces around. Like in C, you pass around pointers and then you pass a second argument, which is the length of the pointer, but then people mess something up, the two values get separated, and who knows, stuff happens. So slices bundle everything together, so it's easier to avoid mistakes. A slice doesn't own memory. A slice references memory that is somewhere else, that is in another variable. So the slice itself doesn't contain that memory. And also, Zig has nice casting rules for slices that we're going to see as we progress to the presentation. Now, let's see. So what should be clear here is that arrays are values. So if you have a variable that contains an array, that is a very fatty variable that contains the whole data. It's not a pointer to that data. That's important. Arrays are values in Zig. Let's talk about slices versus pointers. So here's a few examples of syntax that you can find in Zig. The first one is a pointer to my type. That's easy, right? That's a pointer to that points to a single my type, which is somewhere in memory. The second type of pointer, now we have the brackets again, but we have a star in there. So if these brackets were empty, it would be a slice, but it's not empty. If it had a number, it would be an array, but it's not a number, it's a star. And the star means that this is a pointer to a unknown number of my type. So these are types of pointers that you should not deal with very often, as long as you stay within Zig, as in you're using a Zig library just doing Zig things. But this is basically what C pointers are, more or less, with some caveats, because there are some other concepts about pointers that I've not introduced yet, and I won't cover in this presentation. But the idea is that this is a pointer that, like in C, you just have pointers, and you never know explicitly whether this pointer is pointing to just one copy of your type, or it's pointing to one or many copies of your type. And when I say pointing to many, it means that it points to one, but then if you jump forward the size of one of these types, you'll find another one and another one and another one, which is something that you do in C. That's what arrays are. So in C, you don't get that distinction explicitly in the language, I believe. Well, here we have it. So these two are kind of related, but the square brackets kind of tell you that you are allowed to iterate over them, while here you know that there's going to be only one. No more, no less. Also, you could say, well, how do I know when to stop in here? How do you know how many are there, since you're not telling me? And the answer is, the idea is that the API is telling you in some other way. It's telling you maybe because maybe you are interfacing with a C API, and the C API is telling you how many of these are there through a separate value. Or maybe you know that this is gonna have, at one point you will find a sentinel, a special value that tells you I'm the last one. Maybe it flags it to true, or a null value, for example, in the case of strings. Now again, in Zig there's also sentinel values that it's a new addition that was added recently to pointer types. We'll briefly mention them later, but I'm not covering them now. So in that regard, the point is, if you are dealing with this type of stuff, like null terminated arrays, you probably don't need this introduction. So that's why I'm not going too deep into the detail. But I'm trying to explain why this, which seems kind of worse than slices, is still a reasonable type to have in the language. The final one is a pointer to an array. Now, I put this here just as an example, but you should understand that this final example is actually basically the first example again, right? Because this is a pointer to a type, and in this case, the type just happens to be an array of 5 elements. So this is a repetition, but it's just to introduce the idea that these things can combine, and can combine in very complex ways sometimes. We'll see a few examples of that later, and you need to know how to parse the symbols to understand them correctly. So just a quick recap. Zig pointers can be to one or to an unknown number of elements. Depends on whether there's brackets around the star or not. Pointers to arrays can also convert to slices automatically. That's also another thing that, let me go back. So these can convert to a slice because we know how long this is. We know that it's going to be a slice where the pointer is the pointer here. And since the type is 5, We know that the slice can go to 5. Again, normally slices contain the runtime knowledge of the sequence. There are sequences maybe that depending on runtime conditions can be longer or shorter. But if a function accepts a slice and we are feeding it a pointer to 5, Zig does the conversion for us, which is handy. Okay, going back to here. Third point, pointers cannot be null. In Zig, pointers cannot be null unless you combine them with optionals or you use a special keyword called allow 0, which doesn't really mean that the pointer can be null. It just means that the 0 pointer is actually a valid value for a pointer type. And again, it's one of those advanced things that you don't need to know if this presentation is useful for you. So let's stick to optionals and let me show you, since again, I want to give you an overview of the symbols and how they mix together and how you need to parse and understand what they are doing. So this is a pointer to my type that can also be null. So when if you have a variable called, I don't know, A of this type, you know that inside A there can be either null or a valid pointer to a chunk of memory that contains my type. So to a valid instance of my type. You first unpack the pointer, find out whether the pointer is null or not, and then if it's not, you get access to the type. This is very nice because in Zig, optional pointers don't waste memory. Optional pointers have the same size as a normal pointer. That's very useful. There's also this though. This is a pointer to an optional instance of my type. So you know that the pointer is always valid. That's never a question. But that pointer is pointing to a chunk of memory that is a union of either null or an instance of my type. That's possible too. So the order matters. It's important. A few other examples. Again, this is kind of it gets bonkers after a while. So before everybody gets confused and says, oh, what the fuck is going on? I'm just showing you how they combine so you can understand how they can mix together. And I'm giving you examples of how the meaning changes based on how they mix together. But you normally don't have to do with weird types like this. When you do, there is a reason why you get there, usually. And if you're doing something that makes sense, you will understand why things have to be this or that way. So don't worry. Again, this is just training for interpreting the symbols. So again, this is a pointer to an unknown number of my types. This is an optional pointer to an unknown number of my types. So the pointer might be null or maybe not. But if the pointer is there, it's pointing to 0 up to whatever number of instances of my type. And you can see that maybe you say, oh, wait a minute. So the pointer could be null, or the pointer could be there, but it could still point to 0 instances of my type. That's kind of weird, yes. So there's some nuance there. It's a curious corner case. There's another example here. So that's a pointer that you know is there. The pointer is always valid. But that pointer could be pointing to, that pointer points to 0 to n instances of an optional union of my type. So maybe the first element is a proper instance of my type, but then you jump to the second element and that's a null. The third element, maybe that's a null too. The fourth element is actually a proper instance of my type. So that's the data structure that this type is defining. Now this has 2 pointers. This is a bit more complicated. So the pointer might be there or might be not. But if it's there, then we get back to the previous case. So double pointers, double question marks, that's also, again, kind of weird. So I'm not saying that these are all perfect, but it's just to show you how they combine and how combining them changes the meaning of stuff. Single pointer and pointer to many can also combine. This is a single pointer to a sequence of my type, to a unknown length sequence of my type. This is a sequence of pointers where each element is a pointer in itself. We are back to the square brackets with nothing inside. So this is a slice. So we now have a pointer to one or many slices, but for each slice, the slice we know how many elements it corresponds to, and maybe the first element corresponds to 5 my types. The second element corresponds to 7 my types because that second slice has length 7. Here is the opposite. Here we know the top level. Like at the top, our indirection system has a known amount of elements, but each of these elements is a pointer to a unknown number of my types. And the last one is the, I think, nicest one, where everything is just nested. Again, everything seems kind of weird, a bit too much, but here's one situation where it's useful to know this thing, and you see things getting nested a little bit in a bit less crazy way than this, but it's very useful. And that's these two cases. The first one is a string. It's an array of bytes. The second one is an array of strings. So the double square brackets, they're not, double as in double, two couples of square brackets. These are not uncommon. These are normal. It's not. I don't think it's uncommon to work with sets of strings, arrays of strings, and that's how it looks like in Zig. It doesn't look only like this, right? If for some reason you don't know if you for some reason know at comp time how many strings there are gonna be there, then you will have an array of slices, right? You'll have an array of strings, so maybe you'll have a 10 in here because you always have 10 strings. Oops, and I should not have done that. Or vice versa, maybe you have some particular type of string where you don't know the length in the type in the slice. You know it for another mean, or vice versa. So they combine together. Strings are not just slices to U8, but slices to U8 represent strings usually. And I just wanted to show you two configurations that you will see all over the place. So for example, I think, anyway, let's move forward. So what is a string really? And the answer, as I was hinting at earlier, is a string is many things. There are many things that qualify as string without even getting into the encoding madness. So here's a seemingly innocuous line. You're just saying, well, message is a variable, it's a constant variable, and it equals hello. What's the type of this? Well, we haven't really encountered this type yet. Not precisely. We've got close to it, but we don't know this type precisely. The type of this is a pointer with this const word, so it's a constant pointer to a 6:0 U8. So the :0, this is the terminator, the sentinel type. Let's ignore it for a moment. Again, I'm not saying this is not useful to know. You should probably know about this, but I don't want to get into much of the details in this presentation. But the idea is, this tells you that after the end of the sequence, so at the 7th, there's a secret 7th element to this array that has value 0, value null. Long story short, strings in Zig have, if you have a string literal, there is a null terminator at the end, and that makes Zig strings interoperate with C. So you don't have to do anything; they automatically work. And this is explained also. Like this is also part of the type system. But anyway, let's ignore for a moment this :0. It doesn't exist. But we see that this is a constant pointer to an array of 6 U8s, and that's 1, 2, 3, 4, 5, 6 U8s. So this kind of, if you ignore this small sentinel anomaly, kind of makes sense. But why is it a const pointer? Is it because this variable is constant? That's why? Well, what if we have then var msg is hello? Now msg is not constant anymore. What's the type then? The type is still const pointer. Nothing changed. So what's up with that? The answer is that const variables and const pointers are different concepts. They are not actually really related to each other much or at all. And when it comes to string literals are special cased in all languages. When you have a string literal in your program, maybe there are some weird edge cases where this doesn't happen, but normally string literals in your program get saved in a special section of your executable, and they are referenced from there. So if you have, so that's why MSG is a pointer. Previously, when we had an array, MSG, we had var a equals an array of bytes. The type of a wasn't pointer to, it was an actual array. In this case, that's not it, because everything references that special piece of memory somewhere in the executable. So this is a special case that you have to keep in mind, and that, again, string literals seem the most innocuous thing in the world, but they actually are a particular case. So going back to the original question, what are strings really? Well, strings are sequences of bytes, but string literals are slightly different. They are particular kinds of strings. So what's up with this const thing? When to const, when not to const, what's up with that? This is another thing that I believe bites in the ass people that come to the language if they never had to think about this stuff ever. So let's start with a example program. So this example program has a message, which happens to be a string literal. And then we have these, I would say, very legitimate enterprise grade. I'm pretty sure I had to implement this once or twice in my job as a consultant. And so you have poopy print, and poopy print is just once a slice. It's very simple. Once a slice, and then it prints, adds like important metadata next to your string, and it just prints your string. Seems very reasonable, very innocuous. But you try to compile this, and you get an error. You get that the function poopy print was expecting a U8 slice, but it found the type from before. It found a constant pointer to U60, U8, blah, blah, blah. How do you solve this? Well, let's go back to the previous slide. If you've never done any of this before, you are kind of tempted to fix this, because you say, well, how do I make this a slice then? What's up? What do I need to do to convert this value? And the answer is you can't. You shouldn't. You should not do this, because the problem is that the only fix for this is to make poopy print accept a constant slice. So this is we haven't seen this particular composition of symbols, right, next to another, but this is a constant slice of U8, and this is your best friend. This is probably next to function, const, and var, and the equal sign, and the semicolon. This is going to be the next thing you're going to write over and over again. It's a constant slice of U8. If you don't need to modify the string that you're given, don't ask for that. You say const, so that it means that you don't need to modify it. Now, why was it a problem if without const? And the answer is because this is again, this is these weird strings that get entered into the language, into the executable, and they can be really modified like normal stuff on the stack. They are special cased. So that's why you need the const thing. And again, if something that is const cannot be coerced into non-const. We'll see this later with all the rules. So what's const? As I said earlier, Making a variable constant is a different concept than having a constant pointer. A constant variable means that that variable is not going to change value. So if you make a const a of type usize or type, I don't know, u32 initialized to 42, if it's const, you know that a for its whole lifetime is going to be valued at 42. It's not going to change. But if a is a pointer, which is a fancy way of saying a number, actually, by making a const, you're saying that a is always gonna have value. It's gonna have this always the same pointer. It doesn't say anything about the data referenced by that pointer. While having a constant pointer says that you are not going to modify the data on the other side. And that's important for many reasons, optimizations, special strings, whatever. So the rule of thumb to make your stuff compile then and run is if you don't need to modify a string, always ask for a const slice or a const pointer or const stuff. No, it's actually const slice of pointer. That's it. But don't forget the const keyword. It's important. You're tempted in the beginning to omit it, but because you say, whatever, I'll think about these small details later, right? Because you can always make it variables var and then change them to const later because you're lazy and you're already using your brain power to think about what you're doing. But with pointers, it's not like this. You will encounter problems, especially when you are dealing with string literals, which it happens often, especially when you're prototyping stuff. Let's take a look at all the rules then. So this first element, this is an array. This is an array of 5 bytes. This can become a pointer to 5 bytes by using the ampersand. This is like I think this shouldn't be a surprise, right? That's kind of like in C or all these languages. At the same time, so an array of 5 bytes can also become a slice of U8s by slicing it using the square brackets, but not square brackets single number that only gives you one element inside the array. But if you use, I hope I showed it before. I'm starting to think that maybe I didn't. I think I did it in one of the previous, the first examples. But if you do, for example, a square brackets 5.7, then you'll create a slice that starts from the 5th element and ends at the 7th element. So it points to the 5th element and has length 2. The exclamation point here is just to say that in Zig, this is a small nitpick. Again, if this presentation makes sense for you, you'll probably not care about this small point that I'm about to make, but if the length of the slice that you're trying to make is known at comp time, like if the slicing depends on input that you're getting from the user at runtime, then we can do anything different at comp time. But if the two numbers are, for example, hard-coded in the source file, 5 and 7 are actually written there, then Zig will not produce a slice from slicing, but it will produce a pointer to a, let's use the example 5, 7, right? It will produce a pointer to an array of length 2 U8, which is an interesting thing, which can be useful for comp time. Sometimes can also introduce other problems. But again, just throwing it out there, it's not a big of a deal. That's one of the things that you can forget from this presentation. Next, so we got here, right? Pointer to an array. So we have this pointer to an array, and it can become a slice automatically. So if you have a function that takes in a slice, you can give it a pointer to an array, and it will automatically coerce into a slice. So you don't have to do weird stuff. That's useful. If you have a slice, you can make it become a pointer to an unknown number of elements by doing dot pointer. So if you have a that is a slice, you do 8 dot pointer and you'll get this. I'm giving you all these conversions so that you see a function that takes one of these types, but you have one of the other types, and you would like maybe to know how do you get from here to there. That's how. In general, any of these can become an optional version of itself, but again, the optional has to be on the left. If there's like nested optionals in here, they compose with the inner type, so that becomes a different type. But if it's just an optional on the left, like when something is accepting an optional pointer, you can always give it a normal pointer, long story short. And the same applies to slices and other good stuff like that. When you have a slice or a pointer, I said any, but this actually doesn't really apply to arrays, but pointers and slices can always become the constant version of themselves, but, and this is really important, not the inverse. If you have a constant pointer, you cannot unconst it. Or actually, you can through black magic and other things that have been banned by the Ministry of Pointer Magic, but you shouldn't try to. If you're trying to fix your code and make it compile, you cannot unconst something. You need to const everything downstream. Unless if you really need something to be able to work downstream, like for example, you said, well, I want to give it a string, but I really need to modify it. In that case, then you can't just have a string literal there. You need something different. Let's talk about stack memory. Again, this is not strictly, it's still pointers, but it's from a different angle. It's not about composing weird symbols anymore. This is a different problem, which, again, if you're not careful and you're not used to this stuff, it might bite you in the ass. Let's look at this simple code example. We have a main function, and the main function, now message is not hello world anymore. Now message is the result of calling a function. And this function returns a, oops, again, doing things that I shouldn't do. So this function returns a slice of U8 and not a const slice of U8, which is also interesting. So here we are not using a string literal, but we are using a normal array. And so we make this normal array that contains hello, and we return a pointer to it. Now, this type is not a slice. We know that this type is a pointer to 5u8. But the coercion rules that we saw before say that a pointer to an array can always become a slice automatically. So this works. This compiles. But when you run it, you encounter some problems. One is that, well, if you actually, apparently, at least from my experimentation, if you run it in debug mode, it works. But if you run it in fast release mode, in release fast, you get weird behavior. So you run it normally, this runs it in debug mode, and you get back hello. Sorry, I didn't go through it, but after we get the message, we print it. But if you run it in release fast, then you get question marks. What's happening there? What up? Who ate my letters? And the answer is that we are giving a pointer to memory that is not going to be valid anymore once this function finishes running. So let's go through the points one by one. You have a stack, and on the stack, every time you call a function, a new frame gets placed on. Functions, you always know how much memory it takes to run a function. Let's take dynamic allocation aside for a moment, but without dynamic allocation, you always know how much memory it takes to run a function, because you have three variables. These three variables, one is an array, one is a U32, one is something else. You sum the size, and there you go. You know how much memory you need. So the stack grows by that much. The function runs on that memory, but then when the function returns, the frame gets popped. We free that memory automatically. And the reason why we use the stack and do frames and do this math here is because it's nice, it's fast, it's much easier and less convoluted than like chasing pointers, reference counting, marking stuff on the heap. But the problem though is that if you are in a function, you cannot return pointers to what's inside your function, because everything is going to be destroyed as soon as you return. And if you come from a higher level language and you wonder why are many C APIs clunky in the way that they ask for a buffer and they write in the buffer and they tell you how many bytes they wrote in there, like why is this weird like this? For this reason, because they're trying not to allocate dynamically, which is something that in a higher level language you would do all over the place implicitly. And at the same time, they cannot return pointers to their own memory because that memory is going to be freed as soon as they return. Again, an alternative to resolve this problem would be to so either you pass down a buffer, but sometimes that's also awkward because you don't know how much memory something is gonna need. You discover it only when you go down, when you hop into the inner function, and so your choice is either you give enough memory to be sure that there's enough space, but it's kind of efficient, and sometimes things vary wildly, so you need different mechanisms. Sometimes dynamic allocation, it cuts through all these problems and it just works. But again, bleh. Dynamic allocation, bleh. Here's another example. Now, here's a question. Will this work? I want to see people in chat vote. Will this work correctly? Is this broken? Will this is this gonna work only in debug mode? Is this gonna work also in release fast mode? Okay, we have one yes. I want to see more people. It works. Yes. Oh, everybody knows way too much. Not fun. It's not fun. We need more noobs in here. So yeah, everybody is right. Why? Because hello. So I think this is actually a trip mine that is like the convenience of having strings being interned by the language kind of trips you off because you think you're returning like you could even assign hello to a local variable. The reality is that, well, if you think carefully about what the type system is telling you, you know, it won't work. Thank you, Rudev. Thank you. I know you're doing this just so there is some balance in the force. Thank you very much. Much appreciated. If you look at the type system carefully, you know that if you do var a equals hello, a is a pointer in that case, and it's so not an array type. And so that tells you that it's pointing to something else. Well, you don't know precisely what that something else is, but you know that something is up. But if you're not thinking carefully, it kind of looks like if you do var a equals hello and then you return a, it kind of looks like you're returning local memory when you actually are not. So that's something to think about. So, yep, this does work. Nice. Another example. So this time, we have well, you know what? I'm not going to describe it. I've talked enough about different types and stuff, so I just want to know, is this going to work or is this broken? I know everybody's a pro, so I don't expect good answers, but thank you, Joachim. So yeah, we have a yes. Wait, is that a moon emoji? Is that moon emote? Oh, no, it's a T-Sodin mode. Okay. Okay, we have a few perfectly fine works. Yes. Okay. So, yep. So this works. Why does this work? Because we are not returning a pointer. We are returning the full beefy array. And so what's happening is that here, this message variable that doesn't have a explicit type attached to it, but it's of the type of the return value of the return type of this function. This is not just a pointer. This is a pretty fat array, and this is what we are returning. So the function above us, the function calling getMessage, is the one making space for everything, and that's what we return. And again, that's easy because we know, because 5 is a nice number, but strings in the general sense have a known length, and so that's why you can't use this trick too often, because sometimes it's hello, sometimes it's hello world, some other times is, I don't know, a book. That's the problem with humans. They use varying length strings all over the place. So yep, that works too. Nice. I think we have one final topic then, which is the final operator that we haven't covered yet. and it's the dot star. So when do you use the dot star? Well, let's get to it. So Zig doesn't have the C arrow syntax. In C, if foo is a pointer, so let's talk about structs. If foo is a pointer to a struct, if you want to access the bar field inside the foo struct, you have to use an arrow if this is a pointer. But if you have not a pointer, but the actual struct, so if foo is of type not pointer to struct, but is a struct, then you use the dot. In Zig, that doesn't happen. In Zig, you use the dot in both cases. If you have a pointer to a struct, you still use a dot. And it's not just Zig. I think all the modern languages that do pointer stuff don't have these anymore. Most of them, I think, the mainstream ones. I don't know. So somebody correct me if I'm saying something wrong. Anyway, we saw how, we know that the ampersand grabs a pointer to a value, but the inverse operation, as in I have a pointer and I want to refer to the value itself, it's the star. The difference is that the ampersand goes before the value while the star goes after, but I'm going to show you now how everything works. So let's look at this example. So we have a person struct, and for some reason in our application, we only care how many beans they have. So we have here one instance of a person that has 5 beans. And then we have this function called giveBeans that gives beans to a person struct by writing to the struct's bean property. We need to give the struct, we need to give a pointer to the struct, to the function, because if we don't do the ampersand, if you don't give a pointer to a struct, we're going to give it a copy of this struct. This is going to modify its local copy. The function returns. That modified copy is lost forever. Nothing happened. Super useless. So we give it a pointer to the struct so that the modification happens to our copy that we have here, so that we can use it later. Now here, as you can see, soap in here it's a person instance, while here is a pointer, and here there is a pointer inside giveBeans. We still do p.beans. And also up here, we do, apparently Soap has a secret stash of beans. And when he grabs those beans, we still do dot. In this case, it's a struct. In this case, it's a pointer. So I just wanted to remark the fact that we don't have arrow syntax and what that means. Now, we haven't seen the star yet. So let's go take a look at that. So let's say that a person can have a New Year resolution. And the New Year resolution acts kind of like the giveBeans function does. But in this case, the New Year resolution wants to rewrite, like if you implement your New Year resolution, in a sense, you are a new person, right? You could say. But jokes aside, the idea is that you use the dot star to say, I want to rewrite everything. Dot star is always followed by, when used on the left side, it always used to say, I want to assign every single part of that value pointed by the pointer. And you could use this, well, with structs, it kind of makes sense, but it doesn't only apply to composite types. Like if instead of a person being a struct, we had a number, and this was a pointer to a U32, to change the value pointed by this pointer, you would still do dot star equals, I don't know, 20. So let's take a look at the example down here. And in here, we're also going to see the opposite, the inverse, when we use the star also on the right side. So A is a U32. A pointer is, okay, I'll stop moving this thing because Google Slides wants to show me the menu down there. That's fundamental, absolutely. It's not like I'm presenting or something. So A pointer, by using the ampersand, we get a pointer to A. And then we have B, which is another number. Now, we can do B equals, if we do B equals A pointer, and that's it, we get a type error because the types don't match. But we know that so let's think about it, or let's strip away the type system for a moment. What would mean if we were allowed to do this and there was no type system annoying us? Well, A pointer contains a number pointers are numbers that reference a piece of memory somewhere in your system. So if you have 16 gigabytes, it's a number between 0 and 16 gigabytes. Well, not zero, not exactly zero, but anyway, more or less. So if you just do b equals a pointer, you put inside b the value of the pointer itself. The type system tells you probably don't want to do this. You probably are wrong. That's why you have a type system that helps you fish out those errors. So that's why you do the dot star, because you want to say, I want to assign to b the value pointed by that pointer. And that's what the dot star means when it's on the right side. When it's on the left side, it means I want to change the value pointed by this pointer. So you also do it with numbers, not just structs. I made a point of showing you this and the struct thing, because with structs, if you don't want to change everything, you just do like p.beans equals like we were doing before, right? So you don't use the star in that case. Anyway, I think we've gone through basically all the syntaxes and the basics, and some things are more complicated, some things are less complicated. Wow, that was 50 minutes. So we went through everything. I hope that this was useful for people that are coming into the language and sometimes get tripped by all the pointer symbolism and everything else. So that's pretty much all I have. That's the end. If there's any question in chat or any comment that you want me to read out loud, let me know. Otherwise, that was pretty much it. So let me see what happened. So there's substance that feels being called out. How do you know my secret stash? That's because we don't have private fields in Zig. Your font makes parentheses and graph parentheses look the same. I know that's a problem with a hey, Iridescence Rose. Thank you for the beats. I'm sorry, I don't have animations up. They're disabled. I don't know if I have an animation for the beats, but during the presentation, they turned off. But thank you very much. If you start the parent bracket and then after a while, you can see which it is in the negative space. Yeah. Oh, that's cool. I didn't know you could assign a full struct with the pointer. I assume the new struct would live on the stack. No, I think it writes directly into the memory like this. So I think it's just like a shortcut, basically. But you have I guess the upside in terms of if you had a new field, then it complains that you are not setting a new field. While if you assign every field individually, the compiler doesn't yell at you when that happens. If you do that in C, you will have a bad time. Oh shit. Okay, that's interesting. I don't know. See, I don't think I have I don't think I understand C arrays until up to today. I have no idea how everything works, to be honest. I've been working with higher languages only. Basically, I've always been annoyed at how ugly C APIs are to interact with. Your explanation about them avoiding allocations and stack memory make perfect sense. Thank you very much. I think it's to some degree the same for me. I've always also worked with higher level languages, except very brief moments. And yes, the APIs are sometimes clunky, but they have a reason to be like this, and it's at least to me, using Zig, it's inebriating when you find out that something can be done without dynamic allocation, and you start reasoning about these constraints. And then after, I think this is fun in on itself, but then after that, you can go around and gloat that what you're doing is faster than whatever Java and other things are doing. Okay, from Surat, which vocal exercises do you do to prepare for showtime? I drink hot stuff. That's the only thing that helps. What was the exclamation mark for again? They were actually, I think, mostly for me to make sure I didn't forget. Oh wait, you mean in the language, not in the presentation. In the language, where are those things? Let me see. Do we have slides that show the exclamation points? I don't think I do. I had exclamation points in my slides, but they were, again, as I was saying, like these ones, they were just for me to remember to say something. In my slides, I don't have it, but like the exclamation points denote that a type is a error union, and so it's how Zig moves errors around, which it's basically more or less the same thing that you would do in C, moving like numbers around, except that it is much better from an ergonomics perspective. I have a talk about errors in Zig. It's called Error, Panic, or Unreachable. And if you want to learn more about errors, more or less from the same point of view that I was presenting things from in this presentation, go check it out. It's on YouTube. Like, go to Zig.show, and there you can find a link to the YouTube channel, and there will be the talk. And I guess that's pretty much it. So, yep. I think, let's see, am I missing anything? Nope, I don't think I'm missing anything. Nipsey, I'm assuming that's a link to the talk that I was mentioning. If so, thank you very much. Well, I guess we can move to the end. If you were wondering whether do I have now a spoiler, I don't have any spoiler because, as I was saying, it's kind of becoming harder to think of presentations done in this style. So, we'll see. Do you post the slides anywhere? No biggie. If not, I can look at the recording. I can actually do that if you want. So let's do a compromise. I usually don't post them, but if you join the Zig Showtime Discord, which you can find linked. So if you go on Zig.show, you will find a link to the newsletter. Actually, you know what? This is a bit way too convoluted. Let me just give you a link into each chat. That's easier. Copy link. So this is an invite to the Zig Showtime Discord. If you join, I'll post a link to the slides in there. So that's easy. Because I don't have a, I don't know, good way of doing that. I could probably put that in YouTube, but I usually don't link my slides in YouTube. So I think that's a good way of doing this. Okay, so for next Showtime, as I said, I have no idea what I'm going to present on. I'll try to make more talks in this general direction because I think they're useful for people like me, for dirty web developers, and I don't know, I'm maybe not exactly a web developer, but close enough. Yeah, so we'll see what happens. I'm not sure yet. But what I know is that the other talk is going to be awesome, and it's going to be from Jacob Kupcon, who has been working on making Mac all linking work for the self-hosted compiler, which means that he's been busting his ass on making sure that I can use incremental compilation on Mac. Thank you very much, Jacob, by the way, about that. And he's gonna explain to us what's up with the Mac-O executable format. I'm sure everything is gonna be super simple, easy, elegant, kind of obvious. I can't imagine Apple having weird APIs, undocumented stuff, or something like this. So I'm sure there's gonna be almost a boring talk in that regard. Right? Probably not. There's probably gonna be funny things that he had to deal with in there. So anyway, since that's it, I think that's where the show ends. And thank you everyone for watching, and catch you on the next one.
This is how we